Hello friends, welcome to session 3 of time, speed and distance. In this session, we see upon the concepts around average speed and use of allegations in solving the problems based on time, speed and distance. So what is a average speed? So before coming to average speed, as we know, speed is defined as distance upon time, right? Distance upon time. Now, when the question is what is the average speed? So say suppose a person travels 5 kilometer at 10 kilometer per hour, then another 10 kilometer at say 15 kilometer per hour. So the total stretch of 15 kilometer, this part A where he covers 5 kilometer at 10 kilometer per hour, and then part B of the journey in which he covers 10 kilometer at a speed of 15 kilometer per hour. So we can see speed can average speed cannot be 10, it cannot be 50, it would be somewhere in between 10 and 50, right? 15. What would that speed be? So that we have to find now. So that speed, that one speed, which when multiplied by the total time taken and would give a total length of the journey, so that speed is a average speed. So here, what is that one speed with which if we multiply the total time taken for the journey of A and B together, which gives the total distance, right? So this is what is the average speed. So we can say that average speed is nothing but the total distance traveled upon the total time taken. Now in total distance traveled, when we say in that there may be a part of a distance which may be covered at a certain speed, then another part may have been covered at certain another speed, then another part may have been covered at certain another speed, right? So and thereby taking another some time t1 t2 and t3, right? So therefore the total time taken will be t1 plus t2 plus t3, and total distance traveled would be s1 t1 plus s2 t2 plus s3 t3. So when we divide total distance upon total time, then we find the average speed. So we come back to the illustration here. Now see what is the distance covered in part A, that is what speed into time, right? So distance we know is 5 kilometer, right? So what is time taken? Time we have to find here. So time taken in part A, to cover part A, is distance upon time, which is 5 upon 10, which is half an hour, right? And time taken in part B of the journey is what distance upon again time, 10 by 15. So this we can write as 2 by 3 hours. 2 by 3 hours in terms of minute, it is 40 minute, and here it is 30 minute, right? So now what is total distance covered? Total distance total distance is equal to 5 plus 10, which is 15 kilometer, and total time we have found out 30 plus 40 minute. 30 plus 40 is nothing but 70 minute. So average speed will be total distance upon total time. What is total distance? That is 15 kilometer. Total time is 70 minute. Speed is, say, normal unit is kilometer per hour. So we convert 70 minutes to hour. How to convert? Divide by 60. So when we divide 70 by 60, 60 will come in numerator here. So now this becomes the average speed, that is 15 6 are 90 upon 7 kilometer per hour is the average speed. So it means that now if we multiply 90 by 7, so 90 by 7 kilometer per hour is that speed at which, if traveled on an average in 70 minutes, a person will cover 15 kilometer of total journey. So that is a concept of average speed. So now I will try to deal in some generic variables. Here say suppose a person travels part A, which is d1, at a speed of say u1, and then another part d2 at a speed of u2. So then we have to find the average speed. So average speed, for that, let the part in red A be denoted by A, and let this be denoted by B. So what will be the, or 1 also we can say. So T1, I mean for the first part or for the A part, time taken will be D1 upon U1, and for the second part, the time taken would be D2 upon U2, distance upon time. So now average speed we know is what? Total distance. Total distance is D1 plus D2 upon total time. What is total time? T1 plus T2. This can be written as D1 plus D2 upon T1 is D1 upon U1 plus D2 upon U2, which further can be simplified as D1 U2 plus D2 U1, and in numerator it will become U1 U2, where U1 and U2 are the speed of respective speed. So this is a general, I mean, I'm not at all suggesting that you remember this, but this is the process to find the average speed, right? So here I have done in variable terms. Using this concept we can find the average speed. Now here only two parts were there. Had it been a three part, D1, D2, D3, so we would have done the same thing, D1 plus D2 plus D3 upon T1 plus T2 plus T3, and thereby calculated the same. So this is a generic way of finding a average speed. Going forward, we will see some shortcuts and the application of alligations, which is much more simpler and effective than this way which we have just done, right? So now let's move to the illustrations. Here the question says that Anil travels half of his distance by train at a speed of 90 km per hour and rest half by car at 60 km per hour. Find his average speed for the entire journey. So now see, Anil travels half of his distance. So let this be total distance of this d by 2, d by 2, half of the distance by train at 90 km per hour and rest half by car at 60 km per hour, right? So what is the average speed? Average speed, so what would it be? Time taken in the first part of the journey will be d by 2 upon 90. So here again I take a variable and then I derive one important relation. Let this be say u1 or s1. The speed I mean to say s1, and this is s2. So this becomes, and here also let us assume that the total distance is 2d. Total distance is 2d. So the first part would be d, second part would be d, just to avoid the fractions. Otherwise, I mean, it will hardly make any difference, right? So now I'm going to derive a generic term. So here T1 would be d upon S1 and T2 would be d upon S2. So total time, so now average speed will be what? 2d, d plus d, total distance 2d upon total time T1 plus T2, d upon S1 plus d upon S2. If we solve this, it becomes 2d upon ds2 plus ds1, and here LCM would be s1 s2, right? This we can simply write as 2d into s1 s2 will go to numerator upon d s1 plus s2. D cancels out, so what remains is 2 s1 s2 upon s1 plus s2. This is a very standard result. I mean, this can be remembered because this is very easy, and so average speed is equal to average speed is equal to 2 s1 s2 upon s1 plus s2 when if the two part of the journey, two part of the total journey are equidistant. we should remember we can only use this formula if the two parts of the journey are equal distance. Here it were both were same, d and d. Therefore we can use this formula now, right? So if we use this formula, so in this case it will be average speed will be what, 2 into s1. S1 is given as 90, s2 is given as 60 upon 90 plus 60. It becomes 2 into 90 into 60 upon 90 plus 60 is 150. So therefore this cancels out. 3 2 ja 3 5 ja 5 18. So 18 4 ja 72 kilometer per hour is the average speed. So this is the way we can find. So I mean, it's a very standard thing, and I recommend that we remember this relationship. Average speed is equal to 2 s1 s2 upon s1 plus s2, right? This will actually help us save some time in the calculation, nothing else. Now this is a generic approach. Now I will solve using the method of allegation, which I have already discussed in the earlier discussion on ratio, proportion, and all. So let us see how to using allegation method to using allegation. So I just briefly explain what does allegation here. So allegation here will allegate what, speed. Speed is in what, kilometer per hour. I mean, roughly unit is kilometer per hour. So in allegation what we do, we allegate here, we are going to allegate speed, two speeds. One is 90 kilometer per hour, another is 60 kilometer per hour, and we have to find the average speed. Now typically in bottom, what does it come? In bottom the denominator appears. In allegation, in the usual allegation which we have studied, there the bottom represents the denominator of the quantity which we are allocating. Here we are allocating speed, which is in the numerator. So here denominator should have the time, which is our time. But here we do not know about time. Here we know that distance is given, right? Distance is given. So okay, now since we do not know time, so there are two methods. See, first we know that if the distance is same, if the distance covered is same, so the time will be inversely proportional to the distance. So here we know that at 90 kilometer per hour and at 60 kilometer per hour, the onion covers same distance. So if the distance is same, the time taken will be in reverse of the time taken of the speed. So here speed is in ratio 90 is to 60, which is effectively 3 is to 2. So time will be what, 2 is to 3. Can we say time ratio of time taken will be what, 2 is to 3, because speed is in ratio 3 is to 2. Distance being same, we can say that time will be 2 is to 3. So now if this is given to us, so we can easily find allegation here. Allegation by using allegation rule, average speed here, average speed will be what, 90 into 2 plus 60 into 3 upon 3 plus 2 5. This we should not even write, we should already find this out. So this becomes 180 plus 180, 360 upon 5 is 72 kilometer per hour, right? 72 kilometer per hour. So this is so going forward, I mean, what personally I believe that allegation is a very effective way, and this is the way approach which we should follow. Unless and until it does not give us a very favorable result, or the, I mean, ratios are very awkward, then it may not save time. But certainly it's not going to be lengthier than the generic approach using this variables and arriving at the formula, right? So now again we'll move to question number 2, which reads that a car covered a certain distance at a speed of 120 km per hour and returned back at 80 km per hour. Find its average speed for the entire journey. So now see, here car goes, this is say a length AB, right? So car goes this way at 120 kilometer per hour, and then car returns back at 80 kilometer per hour. But in both the onward and the forward journey, forward and the backward journey, car covers the same distance, right? Car covers the same distance. So we have to find the average speed. So average speed, we know that since the distance covered in the two cases are same, so we can use the formula 2 s1 s2 upon s1 plus s2. Let it be s1 and let it be s2. So we can, why? Because distance covered in two cases are same, that is AB, right? So here it becomes 2 into 120 into 80 upon 120 plus 80, which is 200. So basically it is 96 kilometer per hour. This is using method 1. Now using method 2, that is allegation, we can easily say that since here it is 120 kilometer per hour, here it is 80 kilometer per hour, since the distance are same, the time will be in inverse ratio. So here it is speed is in ratio 120 is to 80, which is 4 is to 3 is to 2, right? 3 is to 2. So time will be in the ratio 2 is to 3. This is time scale, this is speed scale. So average speed will be what? Average speed will be 120 into 2 plus 80 into 3 upon 3 plus 2, which is 5. So this becomes 240 plus 240, that is 480. 480 upon 5, that is 96 kilometer per hour. So this is even simpler. Now moving to question number 3. So in every problem we add a bit of a concept gradually. So this is also on a similar line with just a bit of a modification. So here it reads that a car travels 3/5 of its distance at 75 km per hour and remaining distance at 100 km per hour. What is the speed of the car for the entire journey? Right. So it is given that car travels. Now see, 3/5 of the distance at 75 and remaining distance at, that is 2/5 at 100 km per hour. So see, one thing is, this is 3/5, this is 2/5 distance, 3 by 5d and 2 by 5d we can say. This is at 75 km per hour and this is at 100 km per hour. So what is the average speed of the car? So average speed we know is total distance. Total distance is what? 3d. I mean see, now since here we are encountering fraction, so what I recommend, rather than using 3 by 5 and 2 by 5, what we can do, we can assume this to be 3d and 2d. So now the first part becomes 3d upon 5d, which is 3 by 5, hence satisfying, and the second part is 2d upon total distance 5d, which is 2 by 5. So in that way we can, if the total distance is 5d, so the first part is 3/5 and second part is 2/5 of the total distance. So in this way we can avoid using fractions. So now average speed is total distance, which is 5d, upon time taken in the first part is 3d upon 75 and second part is 2d upon 100 kilometer. So further we can write this as 5d upon LCM of 175 is 300. So this becomes 4 times 4, 3 are 12d, and this becomes 3 times 60, right? So this can be written as 5d into 300 upon 18d. So this becomes 250, d gets cancelled out, 250 by 3 kilometer per hour. 250 by 3 km per hour is the average speed. This is the answer to this question, right, using the generic approach. Now I will solve this using allegation method 2. Now see, just look here very carefully how to allegate the questions based on average speed in a time, speed and distance scenario. So here we know that the speed here is 70, first case 75 km per hour, second case 100 km per hour, right? Since we are allocating speed, so here in denominator ideally it should be time, right? Time, but we do not know time. We know the fraction is distance, 3/5 and 2/5. So what will be time? Now assume that the car was traveling the same distance at 75 and 100 km per hour. So at 100 km 75 km per hour and at 100 km per hour, both the speeds, the car was traveling the same distance. Forget this 3/5 and 2/5. So in the case of same distance, the time would have been the inverse ratio. So here speed is in ratio 3:4. So time would have been the ratio 4:3, right? So but time would have been ratio 4:3 only when the speed only when the distances covered at respective speed was same. However, that is not the case. Distances covered at 75 is 3 by 5, and uh, distance covered at 100 km per hour is 2 by 5. That is, distance is in ratio 3:2. So therefore time taken will also be now directly proportional. Distances covered at 75 and 100 are in ratio 3:2. So therefore time taken will be further, in same ratio. So we'll multiply this by 3 and this by 2. Why 3? Because distances d1 d2 is in ratio 3:2. d1 is to d2 is equal to 3:2. And since time is directly proportional, so we can say 4 into 3 and 3 into 2. So this was an important thing which we learned here. What we will do, we will assume that first the speeds distances covered at the given speed is same. So in that case the time would be just inverse of the speed. Now after having arrived at this, we compensate for the distance variation, the variation in distance, right? So since the distances is in ratio 3 by 3:2, so therefore time would also be in the ratio 3:2. So we'll multiply the respective time by 3 and 2. So here it becomes 12, here it becomes 6. So effectively that becomes 2 is to 1, 2 is to 1. So now we can aggregate average speed will be what? 75 into 2 plus 100 into 1 by 2 plus 1. So this becomes 250 by 3. This is very easy and very less time consuming and very less prone to error as compared to method 1, right? So therefore I say this should be our preferred way of solving the questions based on the average speed, and that is 250 by 3 km per hour. We'll see many problems based on this nature. So now if we look at the question number 4, a car covered a certain distance at 120 km per hour and returned back at x km per hour such that its average speed for the entire journey is 90 km per hour. Find its speeds while returning, right? That is, find the value of x. So important question again. Important in terms of conceptually, we'll see again here how to, again method 1, uh, a car covered a certain distance at 120 km per hour and it returned back. So means it in return journey it covers the same distance at x km per hour. So distances covered are same. So we can say that average speed, which is denoted by s bar, so that we can write at 2s1 s2 upon s1 plus s2. So that we can write as 2 into 120 into x upon 120 plus x, and that is in turn given as 90, right? So 3 times this will go, this becomes 4 times. So basically it becomes 360 plus 3x is equal to nothing but 8x. So therefore 5x is equal to 360. From here we can say x is equal to 360 by 5, which is 72 km per hour. This is method 1. using the generic approach. Now we will see using allegation. Now let us see what happens. So in allegation, we have also seen one cross method when we know the average value. So I mean, we should typically use the cross method. Eventually, I mean, essentially both are same, cross method or the earlier one which we have been using, the straight line method, but just a different way of representation, nothing else. So here the average speed is given as 90 km per hour. One of the speed is 120, and this is x, right? This is x, kilometer per hour. So here time, because this is speed, we are getting speed here, which is kilometer per hour. So denominator here should be time. So time will be in ratio what? Here it will be 120 minus 90, which is 30. So here it will be 90 minus x, right? This is what we do. 120 minus 90 we write here, and then 90 minus x we will write here. So this is the ratio of time, right? And this is the ratio of time, and we know that this is the ratio of time from allegation. However, since the distance is same, distances covered at two respective speeds are same, so the time taken would be just inverse. So time taken at 120 km per hour would be x, and time taken at x km per hour will be 120, right? So these two should be same. These two should be same. So we can say that both the ratios should be same, this one and this one. So 90 minus x upon 30 is equal to nothing but x upon 120. 4 cancels out this, so this becomes 360 minus 4x is equal to x. So therefore x is equal to nothing but 72 kilometer per hour. So this is very effective and very easy. I mean, so uh, and we get the same answer what we had obtained using method 1, right? Now we'll move to question number 5. It says that a car travels 3/5 of its journey at 60 km per hour, and rest of the journey at some other speed, such that the average speed for the entire journey is 72 km per hour. What is the speed of the car during the later part of the journey, right? So in the similar question, but in the previous question the two parts were of equidistant. Here the two parts have different distances. Let us see how to solve. Again using method 1 first. So in the first part of the journey he covers 3D distance at a 60 km per hour. In second part he covers 2D distance. Speed we do not know. However, we know S bar average speed is 72 km per hour, right? And S bar we can also say will be nothing but 3D plus 2D upon T1. T1 is 3D upon 60 plus T2 is 2D upon x, 2D upon x. So this we can solve as 5D upon, we'll take LCM 3dx plus 120d, and then 60x, which was LCM, will come in numerator, and this basically we can equate to 72 km per hour, right? So 12 6 ja and 12 5 ja. So here it becomes 25 dx is equal to, and basically d will get cancelled out also from numerator denominator, so we can eventually take off d. So 25x is equal to nothing but 18x plus 720. So from here we can say x is nothing but 720 by 7 kilometer per hour. This is very close to 103 kilometer per hour. So this is the average speed using method 1. Now let us see how quickly we can solve this using allegation. Right? How quickly we can solve this using allegation. So here we have been given average speed, right? And in the first part of the journey, speed is 60 kilometer per hour. Second part we do not know. So now this axis, the denominator axis of the allegation tree will represent time, right? Because this numerator is speed, which is kilometer per hour, so suppose. So this r is a time, so that will come in a denominator here. So now allegation 60 and 72, difference is what? Say 12. So then here it will be x minus 72. So here I mean x minus 72, then 72 minus 60, that way. Further, what we can say? We can also say that time will be, say suppose I mean what, at 60 and at x kilometer per hour, if the distances covered were equal, then the ratio of the time would have been just inverse x and 60. However, here the distances are not equal. It's in the ratio 3 is to 2. So we multiply this time by 3 and 2, as we had seen in the previous problem, right? Had the distances covered at 60 and x were same, that is at 3 and that is at same, then the ratio of the time would have been inverse x and 60. However, since the distances in actual are not same, that those are in the ratio 3 is to 5, so we multiply the time with a 3 and 5 2, right? 3 is to 2. So therefore if here it becomes 3x and here it becomes 120. So now since that both are time axis and both should be equal, so these two ratios should be equal. So that is x minus 72 upon 12 is equal to 3x upon 120. So here it cancels out 10 times. So we can solve this. It is 10x minus 720 is equal to 3x. So from here we can say x is equal to 720 upon 7 kilometer per hour. Right. So this is pretty easy. I mean quite easy. Now we will move to question number 6 here. So again, now see, a car travels 3/5 of its journey time of the total time. 3/5 of the total time it travels at 60 km per hour, and the rest of the journey at 120 km per hour. What is the average speed of the car for the entire journey? Now see, again using method 1, we can say that average speed is what? Total distance upon total time, right? This is what? Total distance is what? S1 T1 plus S2 T2 upon S1 plus S2 if time is given. So here total distance is S1 T1, that is at the speed of 60. It covered say 3 unit of time. It traveled for 3 units, 3 hours we can say. Or at speed of 120 it traveled for 2 units, and sorry, in denominator it is T1 plus T2, T1 plus T2. Total time will be 2 plus 3 units. So this we can say 180 plus 240 upon 5, right, which becomes 420 upon 5, which is nothing but 84 kilometer per hour. This is using the conventional one, total distance upon total time. We knew the speed, respective time, right? So here we should note that in the previous problems this fraction was of the distance. Now here the fraction was of the time. So when it is time, then I mean the problem becomes less severe. Why? Because we need not deal in terms of fraction as we deal here, right? So therefore it is much simpler. Now method 2 using allegation. So or basically we can use the straight line method here. Why? Because average is not given here. Yeah, so now see, first speed is 60 kilometer per hour and the second speed is 120 kilometer per hour. So And now what should become here? Here is a time axis, right? We have seen, and time is given here. The ratio of time is already given, 3 is to 2. So we need not consider, right? Earlier what we used to do, since the ratio of time was not directly given, we used to derive the ratio of time. How? From the ratio of speed and then multiplying the distance factor. But since directly here the time ratio has been given, so we just use this. So S bar, which is the average speed, is nothing but 60 into 3 plus 120 into 2 upon 3 plus 2. Right? Essentially what we have done here, the same thing we are doing here. So this becomes again 420 upon 5, which is 84 kilometer per hour. Right? This is the answer. Now, if we see question number 7, it says that a car travels 2/7 of its distance at 60 km per hour and 4/7 of its distance at 80 km per hour and remaining distance at 120 km per hour. What is the average speed of the car? So, and since we know that we cannot use basically the allegation approach, we cannot use the allegation approach when there are more than two sort of cases or fractions. Here we have three parts, right? 2/7, 4/7, and then another part is 1/7. So in this case we cannot use allegation. Allegation is only valid for two parts, right? Or the two mixture of two things, ratio of two things. Here three parts are involved, so we cannot use allegation. So we have to rely upon the generic approach. So here average speed is nothing but total distance upon total time, right? What is total distance? Total distance we can assume to be, now see, we can assume first part to be 2D, second part to be 4D, so third part will be D, such that the total distance is 7D, right? Then the fractions are true, 2/7, 4/7, and 1/7. So total distance is 7D, total time and the respective speeds are 60 kilometer per hour, 120, 80, 80 and then 120. So here T1 will be 2D upon 60, here T2 would be 4D upon 80, or T3 will be D upon 120. So S bar will be 7D, that is total distance, upon total time is 2D upon 60 plus 4D upon 80 plus D upon 120, right? So nothing but here we'll take LCM, so that will be I think 240, right? So 4 times 8D plus 3 times 12D plus 2 times 2D, and top is 7D. So here this becomes 7D upon 12 at 20 plus 222D, and 240 will go to numerator. So basically this is 7 into 120 by 11. So 7 into 120 means 840 by 11 kilometer per hour is the average speed. So this is the way we can just simplify or save a bit of a time by being a bit extra smart. And how this approach we have seen many a times, that if such is the case, we can also assume, let's assume that total distance, now here see, total distance we can assume to be is equal to LCM of all the speeds given, that is 60, 80 and 120, and further we can include 7 also, because 7 is there in fraction. By bringing 7 here, what we'll get a distance which is a multiple of 7. So all this fraction would cut off, will go off, right? So therefore now LCM of this will be what? That will be nothing but 240 into 7. So this is the total distance. So first part, d1 is what, 2 by 7. So 2 by 7 means 480 kilometer. So t1 will be 480 upon 60, which is 8, right? 8 hours. Easily we can find. d2 will be what? d2 is 4 by 7, so that becomes 960 kilometer. Then t2 is 960 upon 80, which is 12 hours, right? And d3 is what? d3 is 240 into 7, d by 7. So 240 into 7 by 7, that becomes 240 kilometer. And time taken to cover 240 at a speed of 120 will be what? 2 hours. So here total time is what? 12 plus 8, 20 plus 2, 22 hours. And total distance anyway we know is 240 into 7. So average speed will be total distance upon total time. So that is 240 into 7 upon 22. So here it is 840 upon 11 kilometer per hour. So only benefit here is that we do not have to deal with the variables, and here we have some likeable numbers, no fractions. So therefore the possibility of getting some calculation error is actually quite less here in method 2. Otherwise essentially we are doing the same thing in both the methods, right? Now moving to question number 8. Now see, it is said that average speed of Rajdhani between Kanpur and Allahabad is 120 km per hour, whereas because of the repair activity going on the track between Allahabad and Mughalsarai, average speed of the train on this section is 90 km per hour. Find the distance between Kanpur and Allahabad if it is given that Rajdhani covers the complete stretch of Kanpur to Mughalsarai, which is 600 km apart, in 6 hours. So let us draw the sequence of event pictorially. So let this be Kanpur, let this be Mughalsarai, in between would be Allahabad somewhere, right? Now total distance has been given to be from Kanpur to Mughalsarai. This is given as 120 kilometer, sorry, 600 kilometer, right? Kanpur to Allahabad, the average speed is 120 kilometer per hour, right? So average speed on this part is 120 kilometer per hour, and because of the repair work going on between Allahabad and Mughalsarai, the average speed on this track is 90 kilometer per hour, right? So this is the way. Now find the distance between Kanpur and Allahabad if it is given that Rajdhani covers the complete stretch. So now see, from Allahabad to Kanpur, the distance is, so can we say that speed between Kanpur and Mughalsarai will be total distance is 600 upon time is 6 hours. So this is nothing but 100 kilometer per hour. So here we have been given two speeds and average speed. We do not know the individual distance. Let us assume that to be, let this part be d1 and distance between Allahabad and Mughalsarai be d2, such that d1 plus d2 is 600 kilometer. So this is the pictorial representation of all the statement given in the problem. So now we will use allegation here. That will be pretty simple. We have been given what? We have been given the average speed, which is 100 km per hour, right? The first case speed is 120 km per hour. The second case speed is 90 km per hour. So the ratio of time ideally should be what? Here time axis, it will be 120 minus 100 is 20, and here 100 minus 90 is 10. So that is nothing but 1:2. right? So average speed, now we know that average, what is the speed and what is the time. So total distance we can say here. Now see, we can get from here we can get the answer very quickly. Now the ratio of time, total time is 1 is to 2. So total time is 3 units. However, total time given is 6 hours. So that means actual time will be what? 2 hours and 4 hours, right? So that 2 plus 4 is 6, and that is in ratio 1 is to 2 also. So therefore, what happens? The Kanpur to Allahabad stretch at 120 kilometer per hour for 2 hours, and Allahabad to Mughalsarai stretch at 90 kilometer per hour for 4 hours, right? So to find the distance between Kanpur and Allahabad, Kanpur and Allahabad is 120 into 2, which is 240 kilometer. This is the answer. Allahabad Mughalsarai, the distance is 360 kilometer. 90 into 4. Sum total is 600, right? So this is a very, I mean, question was not a simple one. This is a moderate difficulty level problem. However, we have made this very easy. First part of the problem was to pictorially design it, or draw it on the paper, and then use allegation to find it very easily, right? So this 240 is the answer to this question. What we did here, we allocated speed, we got the ratio of time, total time was given, so we can find the individual time, t1 and t2, t1 and t2. So s1 t1 and s2 t2, this was for Kanpur and Allahabad patch, and this was for Allahabad Mughalsarai patch, right? So therefore we can get the uh, distance, required distance. Now moving to question number 9, it says that a bus without stopping travels at a speed of 72 km per hour, and with stoppages the average speed becomes 60 km per hour, right? For how many minutes does the bus stop per hour, and what is the total time taken by the bus for stoppages on a route of length 540 km? So again, pretty good problem here. Let us see. So here it said that, so say, can we say that bus is running at 72 km per hour for t1 hours, and then in the second case bus is traveling at 0 kilometer per hour because it is stopped for some t2 hours. This is the only case, right? So here we can aggregate the two scenarios. In the first scenario, bus is running at 72 kilometer per hour. In the second scenario, it is stopped at the stoppage with a speed of 0. So now the average speed is given. Average speed becomes 60 kilometer per hour. So the ratio of time will be what? 60 minus 0, 60, and here 12. So that is nothing but 5 is to 1. Total time is in the ratio 5 is to 1. So it means that if bus runs for total of 6 hours, in that 6 hours bus runs for 5 hours and stops for 1 hour, right? Because this part represents stoppages and this part represents runnings. So this means that, so total, what is first part, how many minutes does the bus stop per hour? So in 6 hours bus stops for 1 hour, right? So in 1 hour bus stop for 1 by 6 hours, which is nothing but 10 minutes, right? So this is the answer to the first part. The second part, what is the total time taken by the bus to for the stoppages on a route of length 540 kilometer? 540 kilometer. So here, see, so here what is given? Here it is given that total distance is 540 and average speed is 60 kilometer per hour. So what is the total running time, or I can say time is nothing but 540 upon 60, which is 9 hours, right? So what is the time taken by the bus for stoppages on a route of 540? So on a route of 540 kilometer, the time taken is total is 9 hours, right? Total time is 9 hours. So time on stoppages would be what? Stoppages is 1 by 6. In every 1 hour it stops for 1 by 6 hours. So in 9 hours it stops for 1 by 6 into 9, that is 1.5 hours. This is the answer to this question, right? So nothing, I mean, just the use of allegation and a bit of a unitary method here and there we have used to arrive at the answer. Now question number 10 is a very standard problem we have seen is many of places in many of the textbooks. This has appeared in CAT also, I think. So a car travels downhill from point A at 72 mile per hour, reaches on the level where it moves at a 63 miles per hour and goes uphill at 56 miles per hour to reach point B. The trip from point A to point B takes 4 hours and the return trip takes 4 hours 40 minutes. What is the distance between point A and B? So let us first understand the picture. So there is a downhill first, then there is a level field, and then there's a uphill road. So now this is A and this is B. So in the first instance, the car is traveling downstream at a speed of S1 is equal to 72. Then this covers this part at a speed of 63 and then uphill at a speed of 56, right? Now while returning, what happens? The car travels, now it's downhill, so the speed will become here S3 dash will be what? In downhill the speed is 72, so it will be 72. Now again on parallel slope, this goes in this direction at a speed of S2 dash is equal to 63. And here it will go uphill, and uphill we know that speed is nothing but 56. Now let us concentrate here on, say, let us name this part, this let be M and N. So for the portion AM, the distance is same. In the first instance is coming down a distance AM at a speed of 72, and in the second instance it's going up this distance AM at a speed of 56. So what is the, for AM, what is the average speed? S1 bar, that will be 2 into S1 into S1 dash upon S1 plus S1 dash, right? We can say so. So therefore it becomes 2 into 72 into 56 upon 72 plus 56, and that is nothing but 2 into 72 into 56 upon 128. So here we can say that this is nothing but I think 32 times 4, 14, then again 2 times and 2 times 7. So this becomes 63 miles per hour. Similarly, for the part Mn, average speed S2 bar will be again same 2 into 63 upon 63 plus 63. So that is nothing but 63 only, 63. And then for the part NB, S3 bar average speed, but NB same distance, once going up then coming down. So distance same, speeds are different, so average speed will be 2 S1 S2 upon S1 plus S2. And mind this, whenever we get this average speed, no, average speed is not the 72 plus 56 by 2. When it's a distance, when the distance are same, The average speed will be 2 into s1 s2 upon s1 plus s2, right? We have seen this earlier. It's not the average of 72 and 56. So here it becomes again 56 into 72 upon 56 plus 72, and this we have solved in first part. This is 63. So in all the three cases, the distance average speed is coming to be 63 miles per hour, right? 63 miles per hour. So now we have found the average speed for the different stretches. Now we have to find the length of each stretch. In case of AM actually first it's coming down then going up. So it's covering two times the distance AM, right? So what will be the distance? Distance I will write here. Distance I will write here. So distance here will be 63 at a speed of, then when coming down at T1, and then let me write separately only 63 T1, and then when going up 63 at a average speed 63 for time T2, right? Similarly for Mn, average speed when going towards point B, it is 63 for a time say T2. T2, sorry, let this be T1 dash, T1 dash, and here it is 63 into, when coming back towards A, let it be T2 dash, and then here again when going up NB, average speed is 63 and time taken, let it be T3, and while coming down from B to N, average speed is 63 and time taken is T3 dash. So now when we sum it up, the total distance would be summation 63 T1 plus T2 plus T3 plus T1 dash plus T2 dash plus T3 dash, and this is given as 63 into sum of total time, that is 4 hours plus 4 hours plus 4 hours and 40 minutes. So that becomes 4 whole 2 by 3, that is 4 plus 4 whole 2 by 3. So this is 4 plus 14 by 3, which is nothing but 26 by 3. So here I can write this as 63 into 26 by 3, right? So that becomes, so that is effectively 21 6 ya 126 12 54. So that is 546 kilometer total distance, right? So that is both counting both the distances, going down and then reverse direction. So one way distance would be, one way distance will be 546 by 2, which is 273 kilometer, right? So this is the most basic way of doing, I mean, otherwise we can also, there's another way, we can assume the distance to be some A B C, this distance to be A, this to be B, this to be C, and then calculate the time when coming down and when going up, I mean while on a forward journey and then backward journey, and those times are given and then equate and solve. From that method also we can get that, but I believe this is more conceptual and generic. uh, so using this one we get the answer to be 273 kilometer per hour. So first thing, we got that average speed for the each length AM, MN and NB is 63 kilometer per hour, right? And total time is given. So basically this I wrote just to make sure ki the average speed will be 63 into total time, right? This I could have written directly, but how did it come? For that to derive, I wrote the things separately so that the things become easier, right? So now moving to the last problem I believe for this session, that is question number 11. It says that a husband and a wife, along with their dog, planned a picnic at the top of a hill. The wife, along with the dog, left early for the hill. By the time husband started climbing up the hill in a car at a speed of 60 km per hour, his wife and the dog had already reached at the top of the hill. Dog at the top of the hill spots the car when it is 960 km away and starts running down the hill towards the car at a speed of 90 km per hour. As soon as it meets the husband in the car, the dog turns back towards the top of the hill, to meet the wife at a speed of miles per 70 kilometer per hour. The dog continues this to and fro motion from the top of the hill towards the car and again back to the top of the hill till the husband reaches the top of the hill. Find the distance covered by the dog. So let us see the pictorial representation of the problem first. It says that there's a hill, right? So a family, wife along with the dog plus wife, they already have reached here at the top, right? And a husband has started climbing the hill. Suppose the husband is here in a car, right? Husband is here. So this distance is initially has been given as this distance has been given as 960 kilometer, right? 960 kilometer. And upon seeing the husband coming up, the dog starts running towards him. So dog runs first here. I mean, say suppose dog runs and meets the car here at this junction, and from here the dog meets the husband and then again runs back towards the top of the hill where the wife is there, right? Then again what will happen, then again say suppose dog comes and meets the car here and then runs back and reach here, right? Then again dog comes here, meets the car and then gets back to the top of the cliff. So this fashion the dog is continuing the journey to and fro, right? So first from the point of view of the husband is actually what, the car has to travel 960 kilometer to reach the top of the cliff, right? So car, for the car distance is 960 kilometer per hour, and here the speed is given, right? S1 is given as 60, and here speed of dog S2 is given as, while coming down it is 90, and while S2 dash while going up it is 60 kilometer per hour, right? So these three informations are given. So for the car the speed is 960 kilometer, the total distance is 960 kilometer, and speed is 60 kilometer per hour. So what is the time taken? Total time taken will be 960 upon 60, which is 16 hours. So that is in 16 hours, husband will reach the top of the cliff, right? 16 hours. Now what happens? So basically it means that in 16 hours the dog will keep on running to and fro. So basically it means that dog also runs continuously for 16 hours. However, the speed is not same. In the down movement he is running at a 90 kilometer per hour, in the up movement he is running at a 60 kilometer per hour. So now let us see the case here. In the first case, which is drawn here in green color, the dog is coming down and then going up the same distance, right? It started from point D here, came down to the meeting point, say this, let this be M1, and then again went back to the top of the hill. So distance covered here is both the cases are same. However, the speed in the downstream is 90 kilometer per hour, while moving up it is 60. So since the distances are same, so average speed in the first case will be what? Average speed of dog. Average speed of dog will be what? 2 into S1 into S2 upon S1 plus S2, right? In the second case also, I will not write S2 here, I will write S2 dash, right? In the second case also, in the second for the in the second case of the second meet also, the dog will cover the same distance downward and then upward. Similarly, when the dog meets the car for the third time, then also it covers the same distance downward and the same distance upward, right? So when the distances are same and speeds downward is 90, speed upward is 60, so average speed in all the instances of meeting will be 2 into s1 s2 into s2 dash upon s2 plus s2 dash, that is 2 into 60 into 90 upon 60 plus 90. So this becomes what? This is nothing but uh, 2 into 60 into 90 upon 150. So basically this 0 gets off, 33 ja 35 ja 5 12 ja. So this is nothing but 72 kilometer per hour. So average speed for the dog is 72 kilometer per hour in every trip, for every meet with the car. So say suppose dog meets for n times, but in all the meetings the average speed for the dog is 72 kilometer per hour. So as we had seen in the previous problem, the average speed was same in all the instances. So the total time taken, I mean, so for the total time, I mean for the all the journey combined, the average speed will remain same, 72 kilometer per hour. So we can say that the dog ran for 16 hours at 72 kilometer per hour. So therefore distance covered by dog, total distance covered by dog will be 16 into 72, right? 16 into 72. I believe the calculation is right. Sorry, this is 70 kilometer per hour. 90 into 70 here. So this becomes 2 into 90 into 70 upon 160. So we can write this as, let us keep it same. So here it becomes 9 to the 18, 7 ja 126 upon 16 kilometer per hour, right? So average speed is 1 to, so here we will write dog ran for 16 hours at a speed of 1260 upon 16. So this gets cancelled out. So total distance is 1260 kilometer, right? This is the answer. This is the answer to this question. Or otherwise, what we could have done, we know that now see, we know that speed of dog while going up upon speed of dog while coming down, the ratio is 9 is to 7. So therefore time for which the dog ran up to the ratio to the time for which the dog ran down, that will be reverse 7 by 9. And total time for which the dog ran is 16 kilometer, right? Sorry, 16 hours. And here it is 7 plus 9. So we can say that total time for upward movement by dog is 7 hours at a speed of what, 70. And total time for downward movement by dog is 9 hours at a speed of 90, right? So total distance will be what, 7 into 9, 70. Sorry, here speed upward upon downward is 7 by 9. So time upward upon downward will be 9 by 7. So here it will be time upward is 9 hours at a speed of, upward it's going at a speed of 70 kilometer per hour, right? And downward here it will be 7 hours at a speed of 90 kilometer per hour. So total distance will be what? 9 into 70, which is 630, plus 7 into 90, which is again 630, which again sums to be 1260 kilometer per hour. So this is method 2 sort of, I mean, roughly we can say so. Total distance is 16 hours. Movement upward to the movement downward is 7 is to 9, right? So the movement, the time taken for the upward movement upon time downward will be just reverse, because the distances are same in both the cases, right? We saw that distance downward and distance upward is same, so the time will be just reverse of the speed. So in that case 9 by 7, so 9 into 70 and 7 into 90, that we get a answer as 260 kilometer total distance covered by the dog. So that is the answer to this question. This is a good problem, and we have solved this very, I mean, easily. Both the methods look very intuitive, right? So with this we will close this session. Hope this was useful enough. Any query you can get back to us either on our website or through this on the comment box of this channel. So thanks for watching this video.